Uh, Thanks, everyone. I appreciate the opportunity to speak here today. And what I'm going to be talking about is an initiative that obviously involves many more people than myself. Some of them are in the room. And so it's a collaboration between the University of Alberta, Agriculture and Agri-Food Canada, Huntsman Marine Sciences, University of Manitoba, and the Lake Winnipeg Foundation. And so at this stage, what we've done is we've put in a grant, and we're waiting to hear back on whether or not it will be funded. But in the meantime, we're hoping to undertake a sort of pilot scale exercise on one of the components that we propose to do. And the grant is focused around trifluoroacetic acid. And so prior to today, has anyone ever heard of this chemical or molecule? Raise your hands if you have. I got one, I got two, three. I feel like I'm an auctioneer. All right, this molecule is in you now. You've been ingesting it all day. It's in your rain, it's in your water, it's in your food. And so we're gonna talk a bit about it, but I'm gonna more focus on sort of high level stuff. I'm not gonna get lost in the weeds. We don't have a lot of time, but mainly just what we're trying to accomplish with LWF. And so this is the molecule here. Even if you can go back to your organic chemistry way back when, it's not very complicated. Does anyone sort of recognize what it's similar to? If I took away those fluorines and just put in hydrogens, do you know what I would have? What's that? Vinegar, acetic acid. So basically, trifluoroacetic acid is just another form of vinegar, but it's not necessarily a type of vinegar that we want to be continuously releasing into the environment. And there's a variety of reasons for that. But what I'm going to get into is sort of a little bit more background on what it is, where it is, how it gets out there. But again, very simple, not complicated. And again, much like vinegar, very, very water soluble, so it's able to move around in aquatic systems very easily. And so that's one of the reasons we're looking to partner with LWF, is to try and measure it in our surface waters. So what is TFA? It's a forever chemical. You may have heard this term in the press. More technical term is the per- and polyfluoroalkyl substances, or PFAS. Basically, it's very persistent. It's persistent on a scale that we're not able to really comprehend, right? We sort of, as a default, we say, well, it's got a half-life of 10,000 years. And that's just to give a number. And to give you a sense of the number, that it's beyond our lifetimes and the lifetimes of anyone and everyone we'll ever know, and the people we can imagine. So it's sticking around. It's not going anywhere. Does not bioaccumulate, so that's a good thing. Much like vinegar doesn't bioaccumulate, this doesn't bioaccumulate either, at least not in the traditional sense. What it does do, though, is it builds up in things like plants, because as it's taken up, it's not very volatile, so it doesn't evaporate off. And because it's very persistent, nothing breaks it down, it builds up in plant material. So teas, fruit juices, wines, anything where you're taking plants or eating them that concentrates water over time, TFA can build up in those things. But it doesn't build up in your body. You ingest it. If you were to stop being exposed to it, give it a couple days, it's gone. So it's not building up in you like a classic persistent organic pollutant or POPs that you might be aware of, DDT, PCBs, those sorts of things. Luckily, it has very low toxicity. Because of that water solubility, it sort of passes through, both to humans as well as to ecological entities that it's been measured for. So that's, at least at this time, good news. But the problem is it's beginning to increase dramatically in concentration over time, right? It's fine if it's very, very low, and that's what it's been for a long time. But those concentrations are building, and they're building quite rapidly. And so here we can see some example data from Denmark. If we go back prior to the 1970s and 60s, concentrations in water were very low to non-existent, and I'll get to why that is. But you can see that's been building up. We've gone to very low, and now in about this time in groundwater, about 1 microgram per liter, give or take. And that's sort of what we find in surface waters generally, about a microgram at this time. Here we can look back in time through glaciers and ice caps and those sorts of things, and you can see, again, you go back in time, low to negligible concentrations, if at all. And again, the concentrations have built up, and this is sort of the deposition in micrograms per square meter. And again, you can see that rapidly increasing levels of TFA that are being deposited on glaciers and these sorts of things. And then you're sort of going, well, where's this stuff coming from? If it wasn't here in the 70s, where is it coming from? And the thing is, it's coming from a wide variety of sources at this point. And and this is where it gets very interesting and very complicated, because these are things we use for human health, for crop production, but are also an outcome of the Montreal Protocol, which you might remember is involved in sort of trying to restore and protect the ozone layer and prevent those ozone holes that were sort of a big thing in the 90s. TFA is linked to that. And so what are the sources of TFA to the environment? Here's some examples. Here you've got the corner. You can see TFA again. And so what this moiety, this sort of fluorine moiety, the three fluorines do is provide a sort of stability to these chemicals that allows them to do what they need to do. And so this first chemical here, 2,3,3 tetrafluoropropane, aka HFO1234YF. Does anyone know what that is? Do you like air conditioning? It's a replacement gas for the ozone depleting gases that came in after the Montreal Protocol. And so now those gases don't reach those levels and cause that issue in terms of the ozone depletion, but what happens is they break down, and one of the breakdown products is TFA. Does anyone know what trifluralin is? Yeah, sort of herbicide. And so this gets used, again, breaks down, and what you end up with is pretty much the only thing left at the end is TFA. Prozac, aka fluoxetine. You know, these are antidepressant meds, and a lot of other medicines have that CF3 moiety on it, again, for stability, for other properties to allow them to function. And so again, when this, breaks down and goes to its elemental components, again, the only thing left to a certain degree is TFA. So you can see it's a complicated issue. Lots of different sources, things we rely on for our daily life, all sorts of stuff. And even trying to balance potential existential risks, right? We know the depletion of the ozone hole is not something that will end well for us or ecosystems, right? Like it's a planetary threat. And at the same time, we've got this other issue emerging, right? Just when we think we might have solved something, maybe another issue's on the horizon. And so all of these things contribute to TFA. I mean, this is the beauty of the LWF when we talk about working with them, and the extent and scope and scale of that effort is that network is capturing all sorts of different types of environments, land uses. We've got downstream of wastewater, which is sort of our pharmaceuticals. We've got strictly agriculture, which may capture our pesticide use. And we've also got pristine areas, which would capture that TFA as it comes down out of the atmosphere and would be deposited on the landscape, because that's how a lot of the TFA spread globally. So we've got diffuse non-point sources, and we've got point sources, right? And so this program we're hoping with LWF to try and do some monitoring will help us begin to tease those things apart. And this has been a big question. There's been other sort of like monitoring efforts like this, community-based, in places like England. But if you ever go to those places, it's, you go from town to agriculture to wastewater to town. They really don't have the delineation here where things are, well, this really is just agriculture, and this is pasture, this is crop, right? So we benefit from that. We can start to tease apart these relative contributions, which are a big question right now about where the TFA is coming from. And so with this grant, we had three big questions. What are the sources of TFA? So looking more at the chemistry and how much breaks down from the parent molecule to TFA under certain conditions, the chronic toxicity, and then again the current surface concentrations in Canadian waters, and specifically the prairies. And so that's what we're partnering up with the LWF to do. And so this builds on the salinity monitoring that Braden was a part of and oversaw with the LWF. Massively successful. I can't believe how well this went. 5 years of data. Braden is working it up now. Thumbs up, good, excellent. And again, it sort of shows the power of this, right? The volunteers, the ability to get out there, get these data, and then start to try and understand what's happening. And so right now we've got those 5 years of data, and we're beginning to try and understand what's going on. And so again, it builds on that. We're hoping to do something similar should we be funded. Obviously not at the same scale. Measuring chloride's a little more straightforward than measuring TFA in terms of the costs and the efforts involved. But the beauty of chloride, the beauty of TFA is, I don't know, leave the sample in your trunk, throw it on your roof, freeze it, whatever. It doesn't matter. It's not going anywhere. You don't need to do anything special, right, to sample it, right? There's nothing. This is the nice part. We're trying to partner in a way that makes life easy for everyone, doesn't create any sort of onerous protocols to follow. And so the sampling protocol is very similar to the salinity monitoring. No added risks, right? Basically, you just do what you're doing, and then you will grab another little sample for TFA. Main difference is to avoid as much as we can, quote unquote, contamination, because if you're taking pharmaceuticals that have TFA, you may be sort of producing a bit yourself as you metabolize it. If you're drinking any fluid or water that day, there's the potential for it to be transferred, especially if you drink stuff that's concentrated, so fruit juices or other things. It'll have vastly higher concentrations of TFA than background. And so really what we ask is you wear a pair of gloves that have been provided to you. There's a little bottle we have for a blank. So basically you open the bottle, you just put it down, you sample, you close the bottle up, and we're trying to get a sense of the potential for that contamination. Carl would appreciate all that sort of QA, QC. And again, what we're doing is a scoping exercise. So we're gonna do one time, see how it goes. We're trying to coordinate, so it's just one sort of time point, early May. So for the volunteers, just that week, whenever you're out, just grab a sample. And again, 2026 will be a year for us to learn how it goes, any issues, and we'll inform our 2027 sampling. Maybe we'll identify some hotspots. We might prioritize certain watersheds and take it from there. So many thanks, especially the volunteers, LWF. We couldn't do this without you. And if there's any questions, I'm happy to try and answer them. So, yeah.